Welcome to module 4 of object oriented analysis and design. We have so far taken a look into the difficulties of software development and looked at some of the complexities, the sources of some of the complexities of software development. And then in order to form adequate tools, instruments to be able to handle this complexity, in the last module, module 3, we have studied the structure of couple of sample systems and extracted from the study of those sample systems, we have extracted 5 basic attributes of complex system. We have understood that the complex systems necessarily has to be hierarchic in nature. There has to be a definition of primitives, there will be separation of concern between its components, there will be certain common patterns which we will find across systems, and we will need to define some stable intermediate forms for their development. Equipped with that, now we try to get closer to the design problem, the analysis and design problem, and look into how we handle the complexity better. So, this module will primarily be concerned with the approaches to handle complexity. The module outline as it is to the left of your slide. Now, in terms of handling complexity, we just divide the approach in 2 parts, or we find rather we discover that there are 2 parts to handling complexity. One is, we can say, is organized complexity. Rather, this is a kind of complexity where we are able to find structure, we are able to find patterns, we are able to devise tools and mechanisms by which we can approach the whole problem better. So, we will discuss those and leading to a certain kind of a canonical form, standardized form for a complex system. So, any complex system we want to design, we will try to express that in this canonical form, and that is why it is called the organized complexity. The other part of the complexity, unfortunately, as it stands today, is disorganized, and that has to deal with us. A major or significant component, or the most significant component in the whole process of analysis and design is a human being, because it is a human process. So, unfortunately, there is a severe limitation of the human capacity, and that leads to a lot of complexity of the overall analysis and design problem. We cannot handle a lot of information together. So, when we are thrown into a complex system for the first time, to put it in simple terms, we just get lost. No individual can master and capture that. So, we kind of struggle like a child thrown into the water and trying to learn to swim. So, this aspect of complexity is known as or is characterized as a disorganized complexity, because there is still a lot that need to be developed in terms of techniques, tools and understanding before we can handle this more. And this is one of the major source of issues that will continue to bug us. So, first let us take a look into the organized complexity. We have seen that the complex systems are hierarchic. Now, we go just one step further to say that hierarchy is not one. There are multiple different hierarchies that are possible in a system, and of this, the 2 hierarchies which very significantly impact our analysis and design process are hierarchies of decomposition, which is commonly called the part of our has a hierarchy, and hierarchies of abstraction. Let us take a look. So, we did analyze the structure of a personal computer. A personal computer is composed of CPU, memory, keyboard, hard disk, and naturally we identified that this is a hierarchy. Now, this hierarchy is kind of a compositional hierarchy. So, if we look at from the top, we call this a decomposition hierarchy. That is, if I break down CPU, I will get this component. If I break down a personal computer, I will get these components. If I break down a CPU, I will get ALU, I will get primary memory, I will get buses. If I break down a ALU, I will get register and so on. So, such kind of a hierarchy is called the decomposition or has a hierarchy. Has a in the sense that we can just in terms of simple English phrase, I can say that personal computer has a CPU, personal computer has a memory, CPU has a ALU. So, a short term form of decomposition hierarchies has a hierarchy. In contrast, let us say if I look at the CPU, then I just said that CPU has what is the functionality? It can execute programs. It will have some kind of an ALU memory bus and all that, but we did not say what CPU we have. We all know that there are different variations of CPUs. So, it could be a Pentium, it could be a Pentium MMX, Pentium 2, Celeron, Pentium 3, so on and so forth. It could be Solaris, all these different kinds of alpha CPU and all of these different ones. Now, when we have talked about a CPU, we did not say which specific one is this. So, all these processors are different in their details, but they share the same functionality. The functionality of that of being able to execute a program, access the memory, work through the process and so on. So, we can easily say that a Pentium is a CPU, that is it is an instance of it is kind of a CPU. But then we have Pentium MMX, which is Pentium with multimedia functionality. So, we will say that Pentium MMX is a Pentium, but then it has something more. We will say Celeron is a Pentium 2, because it whatever Celeron can do, whatever Pentium 2 can do, Celeron can also do that. So, we are saying here the notion of hierarchy is little bit different. We say this is kind of a hierarchy. That is one concept, say CPU has different kinds of variations, all of which are actually CPU. One concept as Pentium has different variations, but all of them share the same x86 architecture. So, this kind of a hierarchy, of which we will talk a lot more as we go along, is known as an abstraction hierarchy, or as you have seen that expressions use the simple English phrase of easy. So, commonly it is called a easy hierarchy. Now, these two hierarchies are typically referred in terms of two structures known as the class structure and the object structure. The class structure gives us the abstraction hierarchy and the object structure gives us the decomposition hierarchy. We will show why it is this way. So, all that we are saying that kind of the complex system representation has kind of two orthogonal axes, one which talks of the abstraction hierarchy, the other which talks about the decomposition hierarchy. The one which talks about the abstraction hierarchy we say defines the class structure, one that talks about the decomposition hierarchy we say talks about the object structure. Here please note a couple of points. These are, if you are completely new to object oriented analysis and design and programming particularly, then you may ignore this note, because you will not have this confusion. But if you have some background in OOP, OAD, then you will start confusing this use of the term class and object with what you know in, say, in a programming language, the class in C++ or Java, object as instances and so on. But here we are not talking about those coding details. Here we are talking about higher level concepts that are represented in terms of class and object structures. So, this is a very nice diagram from the textbook that I have recommended to you from the Buch's textbook, and you can see very clearly that here the two different axes are being shown. This is the axis of abstraction and this is the axis of decomposition. So, I can look at but we are looking at the same system. If we look at the same system along this axis, then what we are saying is there is something like class C1. There is something, a concept which is the CPU. Then there are some classes, concepts which are specializations of that. That is, the classes C2, C3, C4 are like C1, but something more. So, if C1 is CPU, C2 could be Pentium, C3 could be the Mac processor, C4 could be the DEC alpha processor and so on. Then we have C7, which is C2. This arrow basically reads EZ. So, C7 is a C2. So, it is a Celeron, let us say C7 is Celeron, is a Pentium. So, we have CPU here, we have Pentium, we have Mac, we have Alpha, we have Celeron. So, in terms of a personal computing system, say that these are different special kinds of CPUs that are possible, and that is what gives rise to the class structure, which say that Celeron has all the properties that Pentium has, which in turn has all the properties that a CPU need to have. Independently, Alpha has all the properties that a CPU need to have. And when we look into the whole system in terms of this commonality of behavior, we say we are looking through the class structure, that is the abstraction hierarchy. On the other, if you look into this, you will find that there are dotted boxes enclosing this. So, it says basically this is one object, this is one entity that we are dealing with. So, this is another entity. So, this, if you look into this object or this entity, then you have this, you have another. So, this is exactly the kind of decomposition that we are talking about. So, if this happens to be CPU, then this could be your ALU, this could be your memory, and so on. So, this is basically the decompositional hierarchy known as the part of hierarchy or the object structure. So, you can look at the whole system in terms of the different objects, different component values that it has, and what is the subcomponent hierarchy in that. So, these are the two key hierarchies through which complex systems of today will be characterized, will be discussed. So, with this, now we say the canonical form of a complex system, we can now describe that in terms of two major properties. One, what we say is a system architecture, that is the two orthogonal view of how does the class structure, how does the abstraction hierarchy look in that system, and what is the object structure, that is how does the decomposition hierarchies look in that system. And these two together is commonly referred to as the system architecture for the complex system. The other is what we have studied in the previous module, the 5 different attributes of a complex system, and in terms of these attributes we need to analyze the complex system and represent that. So, when we do all this together, the 5 attributes and the system architecture, then we say that we have placed the complex system in a canonical form. So, here the main observation to be made, the main advantage that we are trying to drive in is, here we are not talking about any specific complex system. No matter which complex system you talk of, you will be able to represent it in terms of these architecture and attributes, and that is why this is called a canonical or standardized form of representation. And once this representation can be made complete, we will have a much better understanding of the complex system. So, in this process we have found that the overall complexity of a complex system in terms of understanding it, analyzing it, dealing with it, we have been able to somewhat organize it under the canonical form, and that is the reason we call this an organized complexity of the whole system. So, this is an illustration of the canonical form with this is again from the same textbook. So, if you look into this, what it means, this is the class hierarchy, class structure, that is the abstraction hierarchy. This is the decomposition hierarchy or the object structure. And if you look at what these are actually the objects. So, this part which is being added new, this part, the canonical form part, which is actually being added with those attributes, is basically a cross product or combination of these two axes. So, if you look at, you have an object here, and I think this is this object. The object here is this object. The object here is this object. You can just verify. The object here is this object. The object here is this object. The object here is this object. It's basically the same. The object here is this object. It's basically the same objects, but what you can read with a little bit of care. It's I'm sorry, it's not that clear in terms of the size. Is here it is written to be 3, which means that this is this object, which in turn is this object, is a C3 object from class T. This is 7. So, this is a class 7 object. So, you can say that this is a, so this is a C7 object, this is a C3 object. So, this hierarchy tells you that how these objects are going to get their behavior from higher downwards, and this hierarchy tells you, which you represent here as well as here, is how they are put together, how their component structure is. And we will see when we go mature these approaches into defining object models, we will see that these are what we will start calling them as a basic abstraction or inheritance properties. We will start calling them as modularity, encapsulation, and all those properties, but this is a basic system structure that we need to keep in mind. So, I would request that please carefully study this diagram. This is a very interesting illustration of how should a complex system canonically look like when analyzed from the two orthogonal axes of class structure or abstraction hierarchy, which say what is the specialization amongst different concepts in that system, and the object structure or the decomposition hierarchy, which says which is a component, subcomponent, sub-subcomponent relationship. And as a intermix of these two, the canonical form emerge in the middle, which is the system that we are actually trying to build. Now, coming to the other side, so this was about the organized complexity, but finally, the human beings will have to analyze and actually build up this canonical form from as we mentioned earlier, also from some vague descriptions, from some vague interactions, half knowledge, broken ideas, and so on. And when someone is thrown into a complex system, it goes well beyond the comprehension of that person. And here are some of the observations that different psychologists and psychiatrists have tried to quantify over a period of time. What is commonly said is a maximum number of chunks of information, that is if we deal with a simple information, that we can simultaneously comprehend, is kind of 7 for an human individual. Now, for some it could be little less, for some it could be little more, but it is around that number. Now, this chunk of information could be anything. It could be independent concepts, it could be number of variables in a function, it could be the different components or different important things that you see in a picture and so on. But at the same time, we cannot handle too many concepts together, too many chunks of information together, which makes it extremely difficult for human mind to be able to analyze or come to terms with the complex system. And it is believed that this limitation of the human capacity has to do with the imitation of short term memory, which we quickly acquire and quickly forget, and only small number of items can be kept in there. The other limitation which creates a significant bottleneck is the processing speed of the limiting factor. That is, the human brain is extremely slow. So, if we are given with a new chunk of information, we take about 5 seconds to come to terms with it. What is that? What is it meaning? So, only 7, 8 chunks of information, each being processed with 5 seconds, 10 seconds of time, the whole system has a disadvantage of not being able to handle the complexity that one needs to handle. And that is one reason that the whole process of the human engagement in dealing with complex system has to be done through different development of practices, processes, organized behavior, team building and so on. And as I mentioned at the beginning of this module is, these are still being formed and formulated. You must have heard about different paradigms of development, some ad hoc paradigm, some traditional paradigm, waterfall model, and then you have agile, then you have iterative and all those. These are, if you look into it, these are actually attempts in trying to make better and better system, so that from this kind of very disorganized behavior of the human mind, we can take it to a more structured form, where we can handle more information with a less amount of time. But this remains to be a concern area, and really we will not be able to add lot of value in terms of this particular aspects of the whole problem. So, to summarize, we have outlined here some approaches of handling complexity. Primarily, we have talked about the canonical form comprising the system architecture and the 5 attributes. And the canonical form is what you will have to very clearly understand and try to remember, because in the next week, when we start talking about object models and so on, we will frequently fall back on this canonical form for explanation and understanding. And all these together is called the organized complexity, and we have observed that due to the limitation of human capacity, we have a big part of the complexity which is still quite disorganized and difficult to handle. So, in this context, in this background, we are now posed with a fundamental dilemma, that the complexity of the software system that we want to develop is regularly increasing, constantly increasing, and but our own limitations are fixed. Our capacity of being able to cope with that complexity is fixed. So, how do we resolve this predicament? And that is what we will try to outline some of those aspects of how probably we can start handling and behaving this in a way, so that we can handle it better in the next module, in the module 5.